Okay, so in this lesson we kind of combine lessons 6.4 and 6.5 because they cover the same properties and the same shapes. So in this lesson we're going to talk about properties of rhombuses, rectangles, and squares. So our objective is to define and classify special types of parallelograms and to use the properties of diagonals of rhombuses and rectangles. So we've got to be solid in the properties of parallelograms. Opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, diagonals bisect each other. That's what we just got quizzed on. We're going to extend that to more specific types of parallelograms. The first one is a rhombus. And the most basic definition of a rhombus is a parallelogram with four congruent sides. Okay, four congruent sides. A rectangle is a parallelogram with four right angles. And a square is kind of like a combination of a rectangle and a rhombus. It has both of those properties. It has four congruent sides, and it has four right angles. So this Venn diagram below here illustrates important relationships among parallelograms, rhombuses, rectangles, and squares. So we can see that a square is a rhombus because it is a parallelogram with four congruent sides. Because it has four right angles, a square is also a rectangle. So all squares are rectangles and all squares are rhombuses, but not all rectangles are squares and not all rhombuses are squares, because not all rhombuses have four congruent angles or four right angles. Not all rectangles have four congruent sides. So in example 1, we're just going to be classifying special parallelograms. So we're going to ask, is it a rhombus, rectangle, or square? So in part A, this shape, we can classify it as a square. Okay? Part A, this is a square. And the reason it is a square is because each of these is a parallelogram. So that means that opposite sides are congruent, which means all four sides are congruent, which makes this a rhombus. Okay? And the fact that it's also a rectangle, because in a parallelogram, opposite angles are congruent, consecutive angles are supplementary. So it's a square because it has four congruent sides and it has four right angles. So it is a rhombus and a rectangle at the same time. That makes it a square. In part B, this shape is just a rhombus. Okay? It's just a rhombus. It has four congruent sides, but no right angles. So it's just a rhombus. In part C, this shape is just a rectangle. It has four right angles, but not all sides are congruent. Okay, not all sides are congruent. So that's how we classify shapes. We first look at the angles and the sides and then decide, are all four sides congruent? Are all four angles right? So those are the most basic features of rhombuses, rectangles, and squares. We're going to go a little bit more in depth, and we're going to talk about the diagonals and the opposite angles of just a rhombus for now. So a parallelogram is a rhombus if and only if, so it's a rhombus if and only if its diagonals are perpendicular. That means its diagonals create right angles. Okay? Diagonals are perpendicular for rhombuses only. The opposite angles of a rhombus. A parallelogram is a rhombus if and only if each diagonal bisects a pair of opposite angles, which means the diagonals bisect each angle. So in this rhombus to the right, A and C are the same measure and they're being bisected. B and D are the same measure and they're being bisected. So we're going to get some practice finding measures of angles inside of a rhombus. So we got to remember some important features of a rhombus. So in this, AED, the angle AED, the measure of it is 90 degrees because AED is this angle. Okay. So diagonals are perpendicular in a rhombus. So AED would be 90 degrees. ADE if we look at this bottom part of this rhombus as a triangle, the way I'd find the measure of ADE is understanding if in that triangle E is 90, A is 67, I would find ADE by taking 90 minus 67, which makes ADE 23 degrees. So kind of breaking up the rhombus into triangles really helps us narrow down what angle measures are, okay? The final one, BAE, I'm going to use a different color. I'm going to use blue. BAE is this angle right here. Since diagonals bisect the angles of a rhombus, BAE is also 67, okay? It's also 67. And then the final two measures, AE, is just remembering that a rhombus is already a parallelogram, so diagonals bisect each other, which makes AE have a measure of 5 and gives BE a measure of 12. So that's going back to a feature, a property of parallelograms to describe how the diagonals bisect each other. So talking about the diagonals of a rhombus, talking about how the diagonals of a rhombus bisect the angles and how the diagonals form a perpendicular in the middle of that rhombus. Okay, so now that we've talked about some properties of rhombuses, we're going to talk about a property of rectangles. And a property of a rectangle is that for a parallelogram to be a rectangle, its diagonals must be congruent. So in rectangle ABCD, or in parallelogram ABCD, it is a rectangle only if AC is congruent to BD. Okay? Only if the diagonals are congruent. So in example 3, we're going to find the lengths of diagonals in rectangle JKLM. So if JKLM is a rectangle, that means JL is a diagonal and KM is a diagonal, which means those diagonals must be congruent. JL, KM. For that to be a rectangle, for JKLM to be a rectangle, which means these expressions have to be equivalent, meaning 3x plus 4 must be equal to 4x minus 1. So you solve that however you choose. I would subtract 3x from both sides to get 4 equals x minus 1. And then I'd add 1 to both sides to get 5 equals x. So the thing I was asking for from the beginning is to find the diagonal lengths, which means JL is going to be 3 times 5, which is 15, plus 4, which is 19. So JL is 19. KM is also 19. So they're both 19 since they're congruent. So diagonals of a rectangle are congruent. So in part B, I'd like you to try to find the value or find the length of those diagonals if you're given that JL is 2x minus 6 and KM is 3/2 x plus 1. So I'll give you a minute or a few seconds to pause the video, try to work through this, then when you're ready, resume the video. I'll show the answer and then go through example 3. So in part B, just understanding that JL and KM are diagonals of that rectangle, so they must be congruent. So I set 2x minus 6 equal to 3/2 x plus 1. 3/2 x is really 1 1/2 x. So 2 minus 1 1/2 is just a half. So that's how I got 1/2 x equals, or 1/2 x minus 6 equals 1. Add 6 to both sides, divide by a half, or multiply by 2, I get x is 14. Substitute 14 into either expression, you get both diagonals are 22 units long. And then example 3, I kind of go back to an older example, but I'm going to go through example 3 in the guided practice just as examples. So for this to be a rhombus, for what value of x is ABCD a rhombus? It's remembering that the diagonals of a rhombus bisect each other. So that means 6x minus 2, that angle is equivalent to 4x plus 8. So the angle that is a measure of 4x plus 8. So that angle B is getting bisected, which means each part is equivalent. So to solve that, subtract 4x from both sides, 2x minus 2 equals 8, 2x equals 10, x equals 5. And since I was just asking for the value of x equals 5 is fine. Okay, x equals 5 is fine. Now, in the guided practice, I want to show that one because it does cover kind of an interesting property, because it kind of combines the property of parallelograms and rectangles. Because if you remember, in parallelograms, the diagonals must bisect each other, and in a rectangle, the diagonals are congruent. So in this rectangle, let's just make this point P. So in this rectangle, DP is congruent to PF because diagonals bisect each other, but they're also congruent to EP and PG. So each part of those diagonals is congruent because the diagonals bisect each other and the diagonals are congruent. So each part is the same. All that being said, that means 5y plus 3 is equivalent to 7y minus 5. That's all I'm trying to get at, is that each part is congruent there because the diagonals are being bisected and the diagonals are the same length. So if they're being bisected and they're the same length, every part is congruent. So to solve this, I would subtract 5y from both sides to get 3 equals 2y minus 5. Add 5 to both sides, 8 equals 2y. Divide both sides by 2, y ends up being 4. And that's the value of y that makes this a rectangle. So just remembering some of these properties, we will make a graphic organizer to help us remember these properties, help us reference these properties when we're practicing and when we're reviewing and then eventually taking the quiz. So I understand it's more shapes, it's more properties, but we will have something to help us organize that. So you're probably ready to practice this now. I start you off with only a few practice problems and then we build that up later on. So you can move on to the quizzes or the practice, whatever comes next in the lesson.